Good day, everyone, and welcome to this year's hurricane briefing for the 2023 Atlantic hurricane season. So usually this is the format that I tend to follow, and that's what I'll follow again this year. We'll just go over some basics of tropical cyclones. We'll do a quick review of 2022, including kind of a closer look at Hurricane Fiona. Finally, we'll end with the outlook for the current hurricane season and look at what might be in store in the Atlantic for this year. So going over some of the basics here of why tropical cyclones form. Essentially, the energy from the sun really heats up that water in the tropical and even the subtropical Atlantic, and that heat needs to be dissipated in some way. Some of that flows into the ocean currents, but another really effective way that occurs is through the formation of tropical cyclones. So when we have a tropical cyclone, which is essentially a rotating mass of showers and really strong thunderstorms, it rotates towards the center of the storm. The eye of the storm, or the center of the storm, tends to be clear as the air is actually sinking into the center of the storm. But when all of that warm, moist air starts to rise in the storm itself, it cools, and the moisture, there's a lot of moisture in these storms. That moisture condensates and releases a lot of heat, and that's how that transfer of heat takes place from the ocean into the atmosphere. So as long as there's not a lot of wind shear or very little changes with wind speed, with height, and the water is excessively warm, these storms will be allowed to continue to survive and sometimes even intensify. So there's different names that we have for these storms depending on how it gets its energy. So in the case of a pure tropical cyclone, that forms as a cluster of thunderstorms. It starts to get organized. The pressure in the center starts to drop. As that occurs, it draws in more air from the surrounding area. The pressure continues to drop even further. It develops a closed center of circulation, and that's how you get a tropical cyclone forming. There's also something called a subtropical cyclone, which contrary to what some people think, it's not something that forms this exactly the same way, but forms outside the tropics, forms in the subtropics. It's not that. It's actually an existing area of low pressure. So we already have an area of low pressure, already have a center, but it's not tropical in nature, but it starts to acquire tropical characteristics over time, and that is what we call a subtropical cycle. There's also something called a post-tropical cyclone, which is essentially just a former tropical or subtropical cyclone that has maintained some of its characteristics, but it no longer gets its energy from that heat transfer from the ocean into the atmosphere. It gets its energy from differences in temperature in the atmosphere between north and south. So that's the difference between some of these different storms and some of the different names that we use to describe these storms. We know that here in Canada we have a lot of these storms that make that transition to a post-tropical storm, and this is where we tend to find some of our most important hazards associated with post-tropical cyclones. And in terms of the wind speeds, the winds tend to be stronger on the right-hand side of the storm than on the left-hand side. They can still be strong and destructive even on the left-hand side. However, they tend to be stronger typically on the right. And we'll see once we get into talking about Fiona, some of the particularities there. In terms of the rainfall typically always shifts to that left side of the track. You can have some brief heavy showers on the right, but sometimes the sky will clear out completely on that right hand side, leaving all the rain to the left hand side of the track. And because the winds are so strong on the right hand side, that's typically where we find our highest storm surge values and our largest waves as well. So these things tend to form early in the season in the Gulf of Mexico and off the southeast coast of the U.S. The season starts June 1st and extends all the way into November. As we head into the core part of the season, into August and September, a lot more of these storms form further east, often just off the coast of Africa. As we get into October and November, activity starts to subside again. And a lot of the storms that we get in that part of the season tend to be of the subtropical variety, where we have an existing area of low pressure that starts to acquire tropical characteristics, which is a bit different than how they form in August and September. A lot of the drivers, again, around this is the heat that's stored in the ocean, so ocean temperatures. Another very important factor is wind shear, and we'll get into more of this when we talk about the predictions for the season. But during the course of the year, there tends to be higher wind shear, all the way down into the subtropics and even the tropics to a certain extent, because or in our winter season in the northern hemisphere. Also, the ocean temperatures tend to be colder in our winter, obviously, so they tend to warm up over the course of the spring, and they actually peak. There's a bit of a lag. The ocean temperatures in the tropical Atlantic peak towards the end of September. Meanwhile, the wind shear, which is highest in the winter, tends to decrease and typically reaches a minimum sometime in August. So between the time of the lowest wind shear and the highest water temperatures is where we find our peak of the hurricane season, which tends to be in early September, right around September 10th. So those two factors, the wind shear and the ocean temperature, are extremely important in determining the level of activity in the entire basin. So we classify these things based once we've determined that it is a tropical or subtropical cyclone. Once the winds reach 63 kilometers per hour or more, that's when it's classified as a tropical storm and it gets its name. If the storm continues to intensify and the winds exceed 118 kilometers per hour, that's when it gets classified as a hurricane. And there are 5 categories of hurricanes, again, based on the wind speed. So we classify these tropical cyclones based on their wind speed. So looking at some of the numbers from last year, we had 14 named storms. 8 of those became hurricanes, and 2 of those hurricanes made it to major hurricane status, which, if you look at the predicted values for last year, there was actually a pretty good prediction. A bit on the low side with respect to the total number of storms, but still within those predicted values. Of course, Fiona and Ian were the major storms of 2022. And both of those names are retired and will no longer show up in the recurring list of names that we have every 6 years. So it was a fairly interesting season last year. We started off with our first named storm in early June, which was Alex. Then we had to wait about a month for the next storm, which was Bonnie in early July, and then Colin right about the same time as well. Bonnie was an interesting storm, as it remained as a tropical storm in the Atlantic, but it actually crossed over in the Pacific and then actually became a hurricane in the Pacific, but it never became a hurricane on the Atlantic side. But then things sort of shut down from July right into August. There were no named storms in August, but once the calendar changed over into September, we started to get some storm development again with Danielle, Earl, and of course Fiona, and so on and so forth, right up until final storm of the year, which was Nicole. So these are all the tracks of the storms last year. And if we look at the lifespan of these storms in 2022, a lot of these storms over the last number of years, with our increased ability to actually identify these things, a lot of them are of the short-lived variety. So we had 6 of those that only lasted from a day to 4 days last year. However, we did have 7 that lasted a little bit longer than that, and then Fiona lasted over 10 days. So that was the longest lived storm of 2022. Typically go through most of the storms, kind of a walk through the season, but in the interest of time and wanting to focus a little bit more on Fiona, I'm just going to go through some of the more interesting ones as it relates to Canada here. So we had Earl that formed in September, of course, once the season started going again, and that particular storm made its way into our response zone and then kind of really slowed down. It almost stalled, and then just kept pumping rain into northeastern part of the Avalon Peninsula of Newfoundland. So over 200 millimeters of rain was reported there, and there was considerable flooding in the St. John's area as a result of Earl. But the rainfall amounts really started to back off the further west you went because of the position of where the storm actually slowed down. So that was Earl. Then we had Fiona that developed on September 14th, and then ultimately became the first major hurricane of last year on September 19th. It was a major event for Puerto Rico, the Dominican Republic, and Grand Turk, causing lots of damage there. A lot of the damage was as a result of very heavy rain that occurred in that area. So as this was happening down in the Caribbean, we were monitoring this storm very closely as well. Our models really started to focus on a very high impact storm for Atlantic Canada, all of Eastern Canada essentially as well. So we continued our discussions through the weekend of September 16th, 17th, and 18th. September 19th was, of course, a holiday for the Queen's funeral, which added some complexities to communicating with our emergency managers, but we kept in contact with them throughout the weekend into the early part of the week. Once we got on into that Wednesday, September 21st, we were in constant communications with our emergency management partners. Of course, media interest was very high at the time. And even if you look at the track of the storm, 72 hours ahead of the projected landfall, it is remarkably very close to where the storm ended up making landfall. So forecasts for Fiona were extremely good, especially with respect to the track of the storm. On Thursday, the 22nd, we still had a major hurricane on our hands, and we expected this storm to come up and interact with another feature, another trough of low pressure that was moving through Ontario and then Quebec, and was going to cross the Maritimes on that Friday, the 23rd. And so that interaction was going to be key in maintaining the strength of Fiona as it approached Atlantic Canada. So we continued very, very close coordination with all of our emergency management partners on that Thursday. We started to hold media briefings, excuse me, to communicate the potential severity of the storm. And at that time, we started talking about we started using some language that we had never really used before in terms of a historic storm, unprecedented, those kinds of words, which are not used lightly when we're talking about an approaching storm. On Friday, the 23rd, again, that forecast did not change much in terms of the landfall position. But again, we always tell folks to not focus on the exact track, to focus on the potential track area. And at that point, even the day before, it was anywhere from midway through the eastern shore of Nova Scotia to a potential track that took it east of Nova Scotia. So those possibilities were still on the table even a day before landfall. By this time, we were talking about winds of 160 kilometers per hour or possibly more in some areas. Rainfall amounts in the 100 to 200 range in terms of millimeters, and very dangerous storm surge and pounding surf. So that was what we expected as the storm approached. Again, it made landfall around 3 a.m. on that Saturday, September 24th, in eastern mainland Nova Scotia, and then continued into the Gulf of St. Lawrence and then tracked up towards the North Shore and towards the northern peninsula of Newfoundland and Labrador. So what actually happened? Looking at the peak winds, the highest winds that were recorded were 179 kilometers per hour. And that was on the left-hand side of the track. And we know that typically we have our strongest winds on the right-hand side of the track. And that's entirely possible that it happened again with Fiona. It just so happened that those stronger winds, if they were indeed there, did not pass over an actual weather station where we were able to record those. So we suspect there were probably some stronger winds on the right-hand side of the storm, but the strongest recorded winds were 179 on the north shore of Nova Scotia. Widespread areas of winds well in excess of 100 kilometers per hour. And caused a variety of damage from coastal flooding to structural damage. It wasn't just some few shingles blowing off roofs. There were many structures that were destroyed with winds this strong. Massive damage to the power grid. Just a number of different things that occurred with Fiona. In terms of storm surge values, the peak storm surge that we think occurred is right around the Shediac area at 2.5, somewhere around 2.5 meters in terms of storm surge. A lot of focus was on the Port aux Basques area. The storm surge there was 1.1 meters, but what really contributed to some of the damage there was the waves that we'll look at here in a second. But the highest surge occurred in those northerly or northwesterly winds in the southwestern part of the Gulf of St. Lawrence into the Northumberland Strait area. So areas, the North Shore of PI also sustained considerable damage as a result of the storm surge there. We look at the waves. The gray area is essentially the highest waves that were modeled with Fiona. The numbers that you see in the center are actually wave periods, but the colors are the actual wave heights or the predicted wave heights. So wave heights were predicted to be anywhere from 18 meters, and I think the highest or the peak wave heights were around 30 meters, which is is kind of what we see with these kind of storms that are that intense and go through that extratropical transition, or the transition from a tropical to a post-tropical storm. A lot of the damage that we saw in the Port aux Basques area in the southwestern corner of Newfoundland and Labrador were attributed not just to the storm surge, but also the waves as well. In terms of rainfall, here's a map of the observed rainfall. There were some unconfirmed reports of areas in northern Nova Scotia actually getting very close to 200 millimeters of rain, which is not on this map, but it really shows you where the heaviest rain occurred with Fiona. And of course, some of the pictures from the damage. This is in the Port aux Basques area of the storm surge and combination of storm surge and waves. Again, this is a picture from the Canadian Space Agency that they tweeted out a couple of days after, and you can see the silt and sand that was stirred up in the water. That picture on the left is from about a month earlier. You can see how the water and even the coastline changed a couple of days after Fiona as a result of the storm and the strong winds and the storm surge and the waves, et cetera, et cetera. In terms of wind, again, lots of tree fall all over the area that experienced the strongest winds, especially on the Nova Scotia side, in Prince Edward Island as well. Just decimated the power grid in those areas as well. Again, there's enough material to actually do a half-day session just on Fiona, but in the interest of time, just wanted to show you some of the impacts. There were a lot more than what we're seeing here, but it was certainly ended up being a historic storm event for Eastern Canada. We actually set an all-time low atmospheric pressure for the entire country at 931.15 millibars. We recorded that peak gust of 179. Rainfall amounts, as I mentioned, between 100 and 200 millimeters. Storm surge again between 1 and 2.5 millimeters, and the large waves as well. And there are lots of firsts in our operational rhythm as well. We engaged with our emergency management partners very early on, especially in that weekend going into what was turning out to be a long weekend, an unexpected long weekend due to the Queen's funeral. So we started that engagement actually on the Thursday and Friday before, just advising them that we needed to really keep a close eye on this storm. We had many conference calls with our partners at the National Hurricane Center in Miami as well to discuss the storm. We had multiple media briefings and were quite active on social media with in regards to what we were expecting and some of our key messages surrounding the storm. International media was quite heavy, probably the heaviest we've seen. We didn't get any, we didn't break any records in terms of media requests. That record is still stands with Sandy in 2012. However, we probably got the most number of media requests from outside Canada that we had ever seen. We did interviews with CNN, MSNBC, Fox News, even the BBC and the Weather Channel in the US. So lots of attention on Fiona as it approached and as it made landfall as one of the worst, if not the worst, storm to affect Eastern Canada. So as Fiona was impacting Eastern Canada, Ian formed. It formed on the 24th, and it has strengthened to a hurricane on the 26th of September, and then gained major hurricane status just before making landfall in Cuba on the 27th After that, it re-strengthened in the Gulf of Mexico before making landfall as a Category 4 hurricane on September 28th along the Gulf Coast of Florida. So after actually making landfall there, it crossed Florida. It exited back over the water on the Atlantic side, and then made one more landfall in South Carolina on September 30th. So lots of damage. It was certainly the one of the most damaging. It was the most damaging storm make landfall in Florida, and one of the most damaging or costliest storms to make landfall in the U.S. There was a lot of focus as well as the track of Fiona was predicted. The track of Ian got a lot of negative attention, even though it was actually very well predicted. There was a lot of scrutiny on the forecast for Ian, because in the earlier model runs, it showed the storm making landfall a lot closer to the Tampa area, or just south of Tampa, or just rather just north of Tampa, which would have put the Tampa area in a very, very dangerous position from a storm surge standpoint. But that track very slowly started to shift towards the east and southeast. However, the eventual landfall position was in every one of the 24 advisories that were issued by the National Hurricane Center in the days leading up to the storm. So, in other words, the storm actually stayed in the cone the entire time. It was just not very well interpreted in terms of what the locals were seeing. So the focus was all towards Tampa, but not necessarily towards where it eventually made landfall, and it cost a lot of people did not evacuate where they probably should have evacuated, and there were a lot of fatalities, over 150 fatalities as a result of Ian, and 112 billion in damage. Another storm that didn't get a whole lot of attention was Martin. Martin was a late season Category 1 storm, but it actually transitioned to a very, very strong and powerful post-tropical storm, very similar to what Fiona did. And there were actually some modeled atmospheric pressures that had Martin as even lower pressure than what we saw with Fiona. But that remained over the open Atlantic, and I've drawn in the general area of the circulation associated with Martin, and you can see, and this doesn't even take into account the entire circulation, but you can see how this yellow circle compares to the size of the Maritimes, or even all of Eastern Canada. So one of the things that we talk about every year is, the potential for an impacting storm, but not only that, but something that we don't necessarily plan for is for two impacting storms in one particular year, in the same year. So this is another example that you can have two similar storms the same year. We were just lucky that Martin did not come towards Atlantic Canada and stayed further out to sea. So just a reminder that you can get hit by two storms the same year. Final storm of the year was Nicole. It was a late season hurricane, and it made landfall in Florida before coming up the eastern seaboard. Caused a lot of damage, coastal flooding. Some homes were destroyed. Cost over $100 billion in damage. We even signaled some storm surge up here in Eastern Canada as a result of what was left of Nicole as it passed by our area. So this was the final storm of 2022, which was really one of the worst seasons on record, despite only having 14 storms that particular year. So we had 303 fatalities, $120 billion in damage. It was the first time since 2014 that there were no Atlantic storms formed prior to the official start of the season. There was the first time since '97 in which no tropical cyclones formed in August, and only the fifth time overall that's happened. It was the first season on record with no storms in August during a La Nina year, so a year where it favors hurricane development. It was the first time ever during a La Nina season that there were no storms in August. So, very impactful storm season last year, despite only getting 14 storms, which is kind of the long-term average. So what might we expect for 2023? Well, it all boils down to a water temperature. Before I talk about that, I just want to reiterate some of the responsibilities of the Canadian Hurricane Center. So, of course, there were two hurricane centers. One is the National Hurricane Center in Miami. They are what we call the Regional Specialized Meteorological Center. So they have the responsibility to issue track and intensity forecasts for storms across the entire Atlantic. For us here in Canada, we only issue track and intensity forecasts for a subset of those storms, and for us, it's those storms that enter our Canadian Hurricane Center response zone, which is delineated by the thin red line on the map here on the right. So what we would do is 72 hours before a storm is predicted to cross that line, we would actually we would actually start to issue bulletins and track an intensity forecast on that particular storm. Again, it's not to replace what they do in Miami. Like I mentioned earlier, for Fiona, there's a very, very close coordination with our partners down in Miami. We send two of our forecasters down there every spring to do some training with them. And then when we do have a storm, there's a very, very close coordination between these two centers. So we issue information statements on the storms that enter our response zone. So looking at the conditions, the current conditions that we see out there right now, this is a map of water temperature. And there are two areas here that I want you to focus on. First one is in the Pacific. That kind of longer rectangle shows that area along the equator where the water temperature is higher than average, several degrees above average, and that's a condition we call El Nino. So when the water temperature in that longer rectangle is warmer than average, which is, as I mentioned, an El Nino condition, we tend to have fewer storms, fewer tropical cyclones developing in the Atlantic, because in an El Nino year, we tend to have more wind shear downwind, which ends up being in the tropical Atlantic. Therefore, more wind shear, fewer storms. However, if we look at the next rectangle in the Atlantic off the coast of Africa, the water temperatures are extremely warm there as well. And that's another thing that we look at to determine what the activity level will be in the Atlantic. So if we focus on those two rectangles, if we look at what the conditions were last year, we can see that although the water temperature was not as warm in the Atlantic, in the Pacific, it was much colder. So that was a La Nina situation, which tends to diminish the amount of wind shear in the Atlantic, allowing for more storms to develop. Again, looking at this year, we have the warmer water in the Pacific, meaning more wind shear in the Atlantic, but that really, really strong temperature anomaly in the Atlantic. So we have two competing factors here that play into determining how active the season will be. So that's right now. Looking further into the season, this is the predicted sea surface temperature anomaly for August, September, and October, which is the peak of hurricane season. pretty much all the models predict that we will have a very warm Atlantic this year. Even potentially record warmth in the ocean temperatures in the Atlantic this year. Looking at the potential for uh, uh, an El Nino, this is just the brand new forecast off the presses as of early June. And the predictions for August, September, and October is for a 95% chance that we will stay in this El Nino condition. So again, two competing factors. Which one is going to kind of win over the other remains to be seen. But if we look at the predictions for this year, Colorado State and NOAA are the agencies that we really look at in terms of uh, the number of storms or the predictions for the year. Colorado State issued their initial forecast in early April. They updated it um, uh, on June 1st. NOAA, they came out with their initial prediction on May 25th, and they update theirs in early August. And you can see the numbers are very much the same. Colorado State actually bumped their numbers up a little bit by one in their latest update. So that might be an indication that potentially they're thinking the sheer amount of heat that's stored in the water in the Atlantic might emerge as a major factor in this year's hurricane season. So looking at anywhere from 12 to 17 named storms, they have now an identical prediction for the number of hurricanes, which is 5 to 9, and anywhere from 1 to 5 of those hurricanes could reach major hurricane status. There's a fairly large range there, and that just speaks to the uncertainty because of those two competing factors that I mentioned. So you can see how those numbers compared to the average from 91 to 2020. So right around average in terms of the number of storms. And same thing for hurricanes and major hurricanes. There are now multiple agencies that actually throw their hat into trying to predict the number of storms that we'll see. This is the full gamut as of early June for the number of named storms. You can see there's still a fairly wide range with some agencies predicting up into the 20 named storms. So again, it's going to be a matter of which of the two competing factors ends up being the dominant one, and that will determine the level of activity over the course of the season. So we already had a storm already as of early June. That was Arlene. So these are the names that we're going to be using this year. Although it's not predicted that we are going to go through this entire list, but should that occur, we still have our same supplemental list of names that we can go to every year. We made a change from using the Greek alphabet to using this supplemental list of names a couple of years ago. And just again going over some of the resources. The National Hurricane Center in Miami has a ton of information on the history of storms, and also a lot of what you would be looking for in terms of details on a particular storm when a storm actually develops. Should one of those storms move up into Canada or enter our response zone, that's when we would actually start issuing track forecasts and information statements on that particular storm as well. All our information that we issue here at the Canadian Hurricane Center would also be found on our Environment Canada weather app. And we're fairly active on Twitter as well. We have both a French and English Twitter account. So with that, again, the total number of storms is interesting to talk about, but at the end of the day, we prepare the same way every year, regardless of what the level of activity is, because even in a year where there is increased wind shear, you can get these little periods of a week or two where the wind shear subsides. That opens up the window or the potential for storms to develop. And again, we can get some very severe storms, some very impactful storms occurring during El Nino years. So overall, it doesn't matter how many storms actually end up forming in the Atlantic over the course of a season. What really matters is the number of storms that affect you, and it only takes that one storm to make it a bad season, as we saw last year with Fiona. So with that, we'll wrap it up. Thank you very much.